Welcome back to the channel. So today in this video we are going to attempt a miscellaneous exercise on chapter 1, that is sets of class 11th CBSE mathematics. The question is, decide among the following sets which sets are the subsets of one and another. So here we are given with set A, where x says that x is a member of real numbers and x satisfy x squared minus a times x plus 12 is equal to 0. Whereas set B with elements as 2, 4 and 6. Set C is having elements as 2, 4, 6, 8 and so on. And set D is a singleton set having only one element, that is 6 in this case. Now set A contains a quadratic equation which is x squared minus a times x minus 12 is equal to 0. So on factorizing, we'll be having x squared minus 2 times x minus 6 times x minus 12 is equal to 0. Taking x as common factor in these two and 6 as common factor in these two, will be having x times x minus 2 and minus 6 times x minus 2, which implies x minus 6 times x minus 2 is equal to 0. On solving, we'll be having two values of x, that is x is equal to 6 and x is equal to 2. Therefore, set A is having elements as 2, 6. Set B is having elements as 2, 4 and 6. Set C is having elements as 2, 4, 6, 8 and so on, which means it's an infinite set. And set D is having only one element, that is 6. Now clearly, one can observe that every element of set A is in sets B and C. Therefore, A is a subset of set B and A is also a subset of set C. So here the elements of set A, which are 2 and 6, are present in set B and in set C as well. So A is a subset of set B as well as of set C. Similarly, every element of set B is in set C. Therefore, B is a subset of set C. So here also the elements of set B are contained in set C as well. So set B is a subset of set C. Also, every element of set D is in sets A, B and C. So therefore, D is a subset of set A, it is a subset of set B and it's also a subset of set C. As the element of D, which is 6, is present in set A, it's present in set B and it's also present in set C. So set D is a subset of set A, set B and set C as well. Towards the next question. The question is, in each of the following determine whether the statement is true or false. If it is true, then prove it. If it is false, give an example. So part number first is, if x belongs to A and A belongs to B, then x belongs to B. This statement is false. So to prove that this statement is false, let us give an example. Let us suppose we are given with a set A having only one element, that is 2. And we have another set B having elements as 2 and 3. So here one can observe that 2 belongs to A and A also belongs to set B, but 2 is not an element of set B. Part number second, if A is a subset of B and B belongs to C, then A also belongs to C. This statement is false again. Let's give an example. Let us suppose we are given with a set A, again with only one element, that's 2. We are given with set B with elements as 2 and 3. And we have another set C with elements as 2, 3, which is a single element, and another element, that is 4. So here one can observe that A is a subset of set B and B belongs to C, but A does not belong to C. Here part number third, if A is a subset of set B and B is a subset of set C, then A is a subset of set C. This statement is true. Now let us prove this statement. Let us suppose 1 belongs to A, then if A is a subset of B, implies that 1 belongs to B, and if B is a subset of C, implies that 1 belongs to C. This means that 1 belongs to A, as we have had supposed, and we have got this result that implies 1 also belongs to C. So hence A is a subset of set C. So this statement is true that if A is a subset of set B and B is a subset of set C, then A is a subset of set C. Towards the next part. If A is not a subset of set B and B is not a subset of set C, then A is not a subset of set C. This statement is false. Let us take an example. Let us suppose we have a set A with elements as 1 and 2. We have a set B with elements as 2, 3. We have a set C with elements as 1, 2 and 4. Then one can see that A is not a subset of set B. B is also not a subset of set C. But A is a subset of set C. Hence this statement is false. The fifth part. If X belongs to A and A is not a subset of B, then X belongs to B. So this fifth part is also false. Now let us take an example. Suppose we are given with a set A again with elements as 1 and 2 and set B with elements as 2, 3, 4 and 5. So here one can observe that 1 belongs to A and A is not a subset of set B, but 1 does not belong to set B. So this statement is false. Part number last. If set A is a subset of set B and X does not belong to B, then X does not belong to A. This statement is true. Now let us prove it. Let us suppose A is a subset of B. Then if X belongs to A, implies that X belongs to B, and if X does not belong to B, implies that X does not belong to A. Towards the next question. Question number 3. Let A, B and C be the sets such that A union B is equal to A union C and A intersection B is equal to A intersection C. Then show that B is equal to C. Now let us see how this question will be solved. Let us suppose X is an arbitrary element belonging to set B. This will imply that X belongs to A union B. This is because B is a subset of A union B. This implies that X belongs to A union C, as it is given that A union B is equal to A union C. This implies that X will either belong to set A or it will belong to set C. So here we are having two cases. In first case, we'll be having X belongs to A. So this will imply that X belongs to A and X belongs to B. As X belongs to B, this is where we started from. This implies that X belongs to A intersection B, as X is present in both. This implies X belongs to A intersection C, as it's given that A intersection B is equal to A intersection C. So these two statements are given. This is given and this as well is given. So this implies that X belongs to A and X belongs to C. Hence, X belongs to C also. Now let us take case second. So case second is X belongs to C. So therefore, in each case, X belongs to B implies that X belongs to C, because B is a subset of set C. Similarly, C is a subset of set B. Now let us take this as first and this as second. From first and second, we have B is equal to C. Because here we observe that set B is a subset of set C and set C is a subset of set B. So these are subsets of each other, and this is only possible if two sets are equal. Towards the next question. Question number 4. Show that the following four conditions are equivalent. Condition first is A is a subset of B, A minus B is an empty set, A union B is equal to set B, and A intersection B is equal to set A. We'll have to prove that all of these conditions are equivalent. Now let us first of all prove how condition first is equivalent to condition second. Let us suppose A is a subset of set B. This condition by means of a Venn diagram can be shown in the following manner. So a rectangular region, it represents the universal set. The smaller circle, it represents set A, and the larger circle represents set B. And as A is a subset of set B, so the smaller circle is within the region of larger circle. Now suppose we have taken this very condition that A is a subset of set B. This means that all elements of set A are in set B. So set A has no element different from set B. This implies that A minus B will obviously be equal to an empty set. Now let us take condition second and third and show these conditions are equivalent. So A minus B is an empty set. This means that A or set A has no element different from set B. So all elements of set A are in set B. Therefore, A union B is equal to set B. Now we'll prove how condition third is equal to condition 4. So as A union B is equal to set B, which means that all elements of set A are in set B. So the common elements of sets A and B must be the elements of A. Therefore, A intersection B will be equal to set B. Thus, we have shown that first part is equivalent to second part, which is in turn equivalent to third part, and that is in turn equivalent to part 4. Hence, all four conditions are equivalent. Hope this makes sense. Do subscribe to the channel for more such content, and thanks for watching.